Welcome to the first day of the UCAN ULLL Open Fora 2022. The theme for today is digital learning using technology to access knowledge. I'm Pascal Pachou from the Formation Continue, Continuing Education ULLL EPFL, which is the continuing education foundation of the University of Lausanne and EPFL in Lausanne, Switzerland. I'm also a member of the UCAN steering committee. So today we'll discuss digitalization and the use of technology in education. How is technology influencing education and what are the latest developments in the sector of digital learning? Which role do virtual reality, augmented reality play in education, and how we can use these tools in our classrooms and how they can replace or complement more traditional learning approaches. We will have three presenters today. Michael REINER, professor at IMC University of Applied Science, Krems, will give a masterclass on virtual trainings. And then we'll have two people from the Southeast Technological University, that is Colm Dunphy and Neil Willey, who will give short presentations. I'm really pleased to introduce today Michael REINER. We had a chat the other day to prepare this session, and got very excited about his presentation, because when we speak about digital learning, we've talked a lot about blended learning or doing something at distance, synchronous or asynchronous. But lately, I think we haven't really dealt with the new potential of virtual reality. So it's really exciting to have Michael. Michael is professor and senior researcher at the IMC University of Applied Science in Krems. He's also a CEO of the company ECQA. Michael gives lectures on of his product, digital communication, social media, databases, as well as modern IT. He's also leading the EVRI lab, a modern VR lab for research and training, on working with different EU projects. He was part of the Microsoft Academic Advisory Council of Microsoft, as well as a frequent speaker in international conferences. I'll stop here because there are so much more to say, but I prefer to give the floor to Michael for his presentation. Thank you, Michael.
So thanks for the nice introduction. I'm very happy to speak to you today. And as Pascal was already mentioning, if you have a question, just unmute yourself and ask the question. That's fine for me. If I'm going too slow or too fast at any time, please tell me. So it's a pleasure for me to explain to you a little bit about kind of basics about virtual trainings, means trainings in VR and AR, as well as point out some examples, good or bad examples, that I'm aware of. We want to make sure that here we talk about the same thing. So we have kind of the parts of virtual reality and augmented reality, as well as mixed reality. So typically in virtual reality, we see that it is within the glasses and you don't see your surroundings. And augmented reality, you see all your surroundings, and either on a tablet or virtual augmented reality glasses, you see digital informations, and all in between is kind of, for me, the mixed reality part or extended reality. There's a lot of gray zone here that we can talk about. The idea is, of course, if we want to use it, there has to be a business in it. And I've checked out the Statista data, and they were estimating kind of $17.25 billion in the VR market. It came out that there's even more in it, And so the numbers and the figures are even increasing at the moment. So the forecast for 2024 has been kind of since last year already estimated upwards. So we're looking for figures like in augmented reality, roughly 70 to 80 billion, and virtual reality, roughly 70 billion plus, because changes have been made according to new devices coming out, and that always changes the figures a wee bit. So if we are looking at VR, AR in industry or in kind of university setting, we need to talk about some kind of the big part. So in industry setting, retail is one part that you can use it for. It's also kind of part for the entertainment part, which somehow goes back into the university. So if you use it for training, entertainment is also kind of an important part. The security and healthcare part, as well as transportation methods, are a very important part in my point of view. And nowadays you hear the metaverse that often, so collaboration in VR is a very big game changer if done right, but we will come to that later on. So if we take a short look at retail in VR, we have the option of showing some examples.
Lack
So
of confidence and access to
we
the
have
right
kind of
tools
examples
stop
how
many
to
DIY
use it. And
projects before
this
they even
example
begin.
here,
With the overwhelming number of power tool
I'm
today, it's no
getting down a
surprise
little bit,
DIYers are throwing
shows
in the
that in a
towel.
DIY shop, the
Rose
innovation lab
Labs saw
was
an
done.
opportunity
So
to
to
use
try
virtual
out
reality as an
kind of
enterprise
those
solution to develop
devices,
customer and
because if you
associate
buy it and
confidence.
go back, it's hard to imagine how heavy it
Our
is,
test
how
drive
long you will
expands
be
on the
working,
success
how
of the
precise you can work
try-before-you-buy
with that.
model by
And what they
providing
did
a
here is a
multi-sensory
VR
product
environment
education
where they
experience
showed
that
how to
utilizes
use this
haptics,
properly
scent, sound,
and showed,
visuals.
made a game out of it, so
In
kind
its
of
first
points,
iteration,
and then
Rose's customers
got them
learned
to
how
the
to use a
customer
cobalt
and
hedge
got the
trimmer.
good feedback from the
The
customer,
experience
because
teaches
it
product
showed
features,
quite clearly what
safety
it is
tips,
to work
and
with it,
proper tool
and up to a
handling,
certain degree
followed by a
also
guided shaping and
talk
designing
about kind of
session.
the kind of,
Customers have
let's
the
say,
option to
security
enter an
parts
arcade
in a
mode
short
where they
method.
can refine their skills and race the clock.
If we talk to another part of retail, which we all know is of course Amazon or IKEA, where you have the augmented reality part much more present nowadays, where you can look at different kind of objects that you want to buy and place them virtually in your room, scaling them, turning them, changing colors. And that makes the people more confident in buying their products, of course. And that is kind of a very, very big business for the augmented reality part, because you don't need any special devices for that. You can do it with your smartphone, with your tablet. You don't need those fancy glasses that are really, really expensive. And as I said, it's easy to use, it's easy to find on Amazon. And of course, it's done also by the big players all over the world, like IKEA. So you can choose quite a variety, not all of their products, but quite a variety to place them in your own kind of environment. If we talk about hardware, typically if we talk about for VR, you need VR glasses. Please forgive me, I'm not talking about those kind of plastic parts where you put your smartphone in, because that's not VR. That's kind of a part how to make people confident that they don't need VR, because the quality is really bad. And so people feeling sick very fast. So the typical devices from today, Meta Quest or Meta Quest 2, we have the HTC Vive parts with the Rift or the Pro or the Focus. We have from Lenovo some, we have Pico glasses. They all share the same parts. You can divide them in those that are running by being attached with a cable to the computer. So the computer is doing all the calculation power. Or you have those glasses like the HTC Vive Focus or the Quest or the Oculus Rift or the Lenovo, which can be used without any computer. So the application is on the glasses and you are cable free and are free to turn around without being attached to a computer. This, of course, comes with a backdraft, the calculation power, and these easy or even cheap devices is not nearly as good as those from the bigger ones, and of course of the more expensive ones. The same is for the augmented reality part. We have all the augmented reality devices with us, means our smartphones, which we can use. The same for the tablets. The problem is if you want to really use augmented reality, quite often if we're talking about augmented reality if it's hands-free. That means if you don't need to have a device in your hand. And that means the typical devices are the Google Glass ones, the Magic Leap ones, or the Microsoft HoloLens or HoloLens 2, where you have the glasses on. You can see all your real surroundings and the projection projects, kind of three-dimensional objects in your kind of front part. And this one is then either located to a specific part in the room, and it feels for you more or less realistic that this object is there. A lot of things are kind of going on, and a lot of new devices are kind of in the loop for being shown in the next few, let's say, months or years. And everybody is, of course, waiting for the Apple one. So let's keep the fingers crossed, because that could be kind of not a good device, but a very expensive device. But still, if Apple brings in new devices, the information and the interest goes up, and a lot of people are buying it. So it might be a little bit of a game changer. If we talk about virtual reality, augmented reality, we need three-dimensional objects. These objects can be achieved by different kind of meanings. The easiest one is photogrammetry. That means taking pictures with your smartphone, with a DSLR camera. You go around the object, take a lot of pictures, and there's software which produces these three-dimensional objects out of all those pictures. Another option would be the handheld object scanner. That means if you have a smaller object, you can run around with a handheld scanner, and it gives you feedback if you should be slower or faster, if you have the right length and how to do it. The big one is known from kind of geological sites, the Fora laser scanner or any other laser scanner, which produces point clouds, which then afterwards can be used to generate those three-dimensional objects. We additionally use a people scanner, so 3D Scamera or any other kind of part, which is basically a typical photogrammetry part, because the one that you see here has 93 small cameras inside. Every camera is taking 2 pictures in a distance of half a second. And out of these 180 pictures, the three-dimensional object means the three-dimensional body is generated. If we ask the people to stand a wee bit funny, kind of showing the arms like you normally wouldn't do, we know where the joints are and we can animate it afterwards. So it depends all on what you need it for and what effort there is in it that you want to get out for the application later on. So the basic part that you see also virtually behind me is for the hardware for walking. Typically, people are using either the free movement means working with a joystick forward, backward, left, right. That is kind of tricky because people feel very dizzy or even feel not very well after a very short time. The typical and most well taken kind of movement possibility in VR is the teleportation. And then there are the multidimensional motorized treadmills, as you see here. That's an OmniDeck from Omnifinity, which has 16 sections, and you can move in all directions. And if you move, those treadmill parts or sections are trying to bring you back into the middle. And that means you can move virtually forever, but you are physically moving, and that is much better perceived by the body and the brain than this typical free movement or the teleportation part. We have one of those 5 treadmills in Europe. And if we change the speed a wee bit, you can go up to light jogging on that one. It's kind of really interesting for kind of typical kind of thesis parts or things like that. If we talk about hardware, not only for moving, but also for feeling, there's quite a variety of haptic gloves coming out and also be there. We have kind of with Tesla suit, haptic suit that you can pull on, which gives you feedback by kind of speakers that are implemented there. A little bit more creepy is the smelling in VR, which I find a little bit discussable in the ethical part, because we all know you can ignore visuals, you can ignore sound, you can't ignore your smelling. That's something. I tried it out in Amsterdam, and it really, really is something which should be quite good thought of. but the haptic gloves are really nice. So there are easy ones just to show your fingers while you're moving them, or even those with feedback, which you give you force feedback for every finger. The problem is the new ones are already lighter, but the prototypes beforehand were 3 to 4 kilo per hand, which is kind of tricky if you want to use it for a longer time. For the industry, of course, it's important to think about, or even for a university, for training methods, why? And the question I'm always asking, because we get asked quite a lot, can we do a project together, is, okay, what do you want to do with it? Isn't the monitor enough? And that's a good question. And I'm not asking it because I want to tease the people, but quite often I see examples of virtual reality where the question is, why have you done it in VR, or why have you done it in AR? Why not on a monitor? And the planning is it. So what do you need it for? But still, if you talk about the immersion rate, that means how it is perceived, it's much higher in VR than on the monitor. And the problem is, if you look at a three-dimensional plan, quite only a few people can really make a 3D model in their brain with it. And if you are walking through a planned building, for example, in kind of AutoCAD or any other of the CAD programs that are out there, it makes much more sense for you to see problems or change needs, or even get a perception of what you should be aware of if you walk on it. And the same part goes on whole buildings. So we have kind of a house building company nearby here. They're doing every house now with every person that wants to buy a house in VR. That means they invite the people, say, well, listen, if you invest kind of 200, 300, 400,000 euro into a house, just make a short trip to us, take a look at the house that is there and walk through it and think what you want to change, or what you will be in need of it. We can change the weather situation. We can change from spring to winter time to see how the lighting changes. And by that, planning where we want to do it before even building it. And that is kind of a game changer, because, well, if you turn the house a wee bit, some degrees, it would have been much better in terms of the light situation. Turning it later on when it's already built might be a little bit more tricky. So that's one of the reasons why VR here comes quite good. And a lot of those software parts are already using it. That means we do have kind of the part of the industry that are using typical industry software, like the Autodesk part, where there's a section within that is capable of doing a virtual reality environment for you almost automatically. There are some backdrafts and some kind of quality parts, but they're doing a very good job there outside of the specialized softwares. And if it kind of comes to content creation and you want to work together on a three-dimensional object, personally, I think VR will be one of the futures, or even AR up to a certain degree. But I think that is one of the big parts that we will be seeing in VR in the future. The training in VR, either for industry or for universities, is of course out of a good reason. You can train on non-existing places, for example, on an oil rig that is not built yet. You can train your people, or you can train people with kind of security issues. That means if you have a wind turbine and you want to train the people how to behave up there, it's not very clever to start the training up there. But under certain circumstances, some trainings are also kind of not very realistic. So angry customer training is also already done in VR, or kind of speaking in front of a large audience can be done in VR. There are applications for doing so, because a lot of people are having problems with these kinds of parts. The important part is, of course, if you do a training in VR, we need to make sure that the people are allowed or even do make mistakes, but they should be shown that this was a mistake, and then get kind of the feedback, okay, that was a mistake and that shouldn't be done again, and to prevent the people from doing the same mistake 2 or 3 times. So by this learning the mistake. The idea of a complex situation and collaborations, for example, simulation of an accident on the motorway for working together with kind of police, with fire workers, and with kind of helicopters landing there, is a very, very complex situation that is really hard to train, because you need to go to a motorway, you need to close the motorway, you need to bring all the people there. And doing this in the virtual reality environment is a much better part and still a very realistic part. And those kind of insights that you can have, and the typical example is always kind of medical parts. For example, if you look at the heart and you can slice the heart while it's still beating, and you see how the valves are working, or how is a stent being set in, these kind of processes, you have a very high insight if you use this in 3 dimensions, because we all are in a 3-dimensional world. If you look at the wind turbine example, we have the problem, as we said, that we have a lot of security issues. And if you show this to the people, it's a very realistic one. You feel very uncomfortable if you are in the virtual wind turbine. You don't need to be 100 meters above sea height. And if you go inside, you can really train how to open this box, how to switch off, switch on certain parts for security issues. So what do you need to do? There's also a manual for you, which you can take a look at. And those are the parts which help you to make sure that people understand. Here in this example, you see the controllers. This, of course, can be changed by showing real hands, or then even with the haptic gloves, having a different kind of feedback for that, making it even more real, and by this adding to the training experience. So what we have, of course, is kind of the need of going on. And as I said, for the security part, Osha here has a wonderful example of what to do. That means the first part is all about safety compliance. That means what you need for dressing, kind of helmet, security parts. And this is about the storage house. And they have done kind of certain issues where you need to take care if the others have taken all the security issues, where you see, well, to yourself, if I put on the helmet in VR, I see also here in the mirror of your helmet. And later on, it's all about how to behave. So what is wrong in this room now at the moment? Are there any security issues? Can I see them? Can I point them out? And at the very end, they are setting the whole room on fire and you need to go out. I've talked to some people that went through the training, and I said, it's really, really creepy, because that is so realistic if the whole building starts burning. So I'm not quite sure if this is a good training for everybody, but it's very realistic, and you have kind of those issues where you need to take care and need to be trained if you see them or not. And the same issue is, of course, for the Austrian Railways company. That's a demo we did for training how to prepare a train before driving. They have enough driving kind of simulators, but it's all about the process in the back. So that means which step to take first, because typically they put a train there, they go in with one trainer and one trainee, and this one takes 45 minutes to explain, then they go out, take the next one in. And that's such a waste of material, because the train has to stand there for a whole day. And here, that example, for example, also talking about collaboration, you have the chance of walking virtually with 20 people in the same train, explain it once, and let the people try out things. So we have also kind of different setups, a typical open training. We have kind of the typical training that you can do together with others. And we have the training where it's all about safety parts in the beginning, where you need to walk along, you take your safety vest, your helmet, and everything as you have seen in the demo before. And there's a typical exam mode where you're walking through the same demo with an examiner. The examiner has a virtual tablet in front of him, and everything you do, he sees instantly that it's ticked and that's passed. So we can do a lot of things here. We have in the automotive industry a lot of parts of selling, kind of showrooms. The assembly process is tested virtually. That means the people can work on their assembly workshop and then checking for optimizing of their ways, or what height do they need for different kind of tables, and it's also a health issue. And that's kind of the training and qualification with VR. That means people can be trained, can be prepared for different kind of working plans or even different kind of surroundings. I'm not a fan of virtual meeting rooms as long as it's only talking to each other, because, well, we all see we have kind of GoToMeeting, we have Teams, we have Google Hangout, we have a lot of online collaboration and talking tools. We don't necessarily need the virtual reality part for that. It is different if we have three-dimensional objects which we can discuss and turn around and take apart. So that's kind of a different kind of setup. And in the medical industry, we have anatomy courses taking people apart step by step. We can plan the facilities, kind of how to plan the facility and what kind of object to put inside. Is there enough kind of room? Is the cable length enough for the next power plug? And all these things, because if this room is finally built, you don't want to remove the kind of objects there again and build it new again. So that's kind of really extremely expensive. And of course, I'm happy of people training operations virtually, because if the operator is doing the operation not the first time, but at least has done it virtually 5 to 10 times, I'm much more confident that it will also kind of work. I've got an example of a very tricky brain tumor, and we had kind of a company supporting this in the healthcare. So they took the scanning data, printed the head in three-dimensional objects, and made this object available for the person to really train it. So it is kind of a operation he has done with VR glasses out of a tracked down object, but has the haptic feedbacks of everything, kind of the drill and everything that he was in need of. And that is kind of a very cool combination that solves the haptic feedback and gives you all the information you need for the VR part. For the collaboration and demo tools, as we said, there are a lot of those out there, like Altspace VR, Meet in VR, Glue. Quite a few of them are free of charge. That means you can set it up by yourself. Free Facebook Horizon. Oh, sorry, it's not Facebook anymore. It's Meta now. So I have to change the presentation again until they change the name again. And these collaboration tools means you have a lot of people with VR tools looking at each other, their avatars. It gets a wee bit kind of interesting or kind of creepy if these avatars are too free to use. I'm not quite sure how many of you know the part with Second Life, because that kind of did the same thing because of having a lot of avatars in the beginning and selling kind of goods in the virtual environment. That's kind of a part where a lot of kind of money is seen. We will see what this brings for next for us. The problems is you need to know which headset for what task. That means it's not kind of going to the next store and buying a headset and this one suits everything. It's about the quality of displays, pricing, support, management. How long do you want to use it? Is it for a short-term training, half an hour? Is it for a long training, 2-3 hours of training? And you need to be kind of sure to use the right hardware for that. Will the participants be able to use these headsets, so like disabilities, wearing of glasses? Most of the headsets allow wearing glasses, but still the comfort is, well, let's put it that way, not the best all the time. And we need to talk about safety issues in terms of data. That means what information of the application is saved. We had the issue with the Austrian railway system, where we first of all thought of a wonderful glasses with eye tracking to make sure that people look at the right space, but we weren't allowed to use it in the very end because we weren't allowed to use the eye tracking data. And if you have trainings, it's all about health situation, also kind of cleaning of headsets. Is it only cleaned like we have seen it quite often, like kind of with a tissue cleaning the headset, which is not cleaning, it's kind of going over it? Or is it with a UV ultraviolet lamps? Kind of there are boxes for that, like clean box and things like that? Is it a kiosk mode or an open headset? That means kiosk mode, only one application is allowed and the people are only using this application. Or is it an open headset? Especially in universities, we have seen some solutions with open headsets going really wild because the students were very creative on what to put on the headsets. So not the best setup for that. And we need to talk about multi-user or single-user setup. Is it better to train on your own and concentrate on that? Or is it better to train together with others to discuss? And where is the advantage of that? And that was a very fast run through. So if any question comes up, just allow yourself to ask the questions. I hope I wasn't too fast.
Thanks very much, Michael.
Welcome.
The floor is open for questions.
Thanks very much, Michael. Really interesting presentation.
Thanks very much.
I worked a little bit with VR in a previous university where we had a VR lab, and their job was to try to attract lecturers in to see how they could apply VR to their educational context. So you got a lot of the engineering people, a lot of the architecture, a couple of the medical people. But how else do you see it being applied in the educational context, aside from these ones which lend themselves well to VR and AR?
Well, we have kind of a running idea which is now discussed on the terms of how we can kind of really come to it by introducing VR to school people, so pupils. And we have just started now for kind of biology classes supported by VR. So we did kind of offer 3 selected schools here in Krems. The VR equipment means we bought Meta Quest 2 for them. And we are now into kind of doing these kind of, you know, these 3-dimensional plastic puppets with the organs, which you can take out the brain, you can take out the heart and everything. We have one at the university, but due to the fact that these puppets are about 4,000 to 5,000 euro, typically you won't find them in the schools. So we did a scan of all the organs. We did take the school books of the biology class, and we added a little bit of information to every organ. And now there's a game in VR where you can kind of put together these organs to a whole body, and it takes time, like gamification, because the kids are loving it. And it's just a wee bit teasing of information for the liver, for the heart. It's not everything from the book, because I want them to go to read the book. And that's kind of the part where I want to have the combination of both and not kind of post everything in the application, which would be easy.
Kind of a blended version. It's really clever, really good idea. Yeah.
And I'm very much into looking into other ideas, because that will be our first teaser for the teachers. And then I hope that a lot of teachers, like history teachers or geographic teachers, or even mathematics of displaying numbers in a 3-dimensional way, will come to an idea of how to use it for them. Because then generating the 3-dimensional object is our daily life, but having ideas where to apply it, and having dedicated people who say, I'm willing to invest some time and use it together with my kids or students or whatever, that's the tricky part most of the time.
Thanks, Michael.
You're welcome.
Michael, what would be your advice if a school, a university approached you and told you, we want to get into that field?
Stay patient and have good nerves.
And money.
And no. The funny part is there's a lot of funding out there for such things, for digitalization, for new ideas, for coming up. And there's a lot of money in it. The problem really is you need to have people that are willing to try it out and invest time. And that's the most important part. So there's no need in me generating applications and then handing it to teachers that don't want to use it, or to lecturers that don't want to use it. No way. You need to have them being interested, and that's the first step. So we are inviting a lot of people in our Every Lab. We have done a virtual playground where the kids can run around, throw a hammer through the whole virtual lab. They can crush kind of blocks. They can climb virtually up there. They can do a lot of nonsense. But this is where the teachers that are with them see that they are interested. And it's a typical gaming aspect. And then everything else will follow. But you need to have the people willing to invest the time. And then, of course, well, on the second level, you need to have people generating the content for that.
We have a question in the chat by Burkuer Turkilic. What do you remember as the best and worst examples for the application of VR, AR in trainings?
Well, if we skip the training part, the worst application in VR, AR is very easy, roller coaster. As long as you're not sitting in a real roller coaster with virtual glasses. If you're sitting in your chair with roller coaster, I can guarantee you that you're feeling sick in seconds.
Okay.
That's a wonderful idea of having roller coaster without moving your body instant. The best VR application, well, I should say our application, but it isn't. So unfortunately, I've seen a lot of really cool virtual applications, but I think in terms of easiness of approaching it and how much people it took into virtuality, I have to say Beat Saber. It definitely. You wouldn't imagine how many people are playing it and still playing it and having played it with thousands of variations. And it's so easy and so kind of, and they're competing at each other. So we have the gamification part again. They have high score lists. They are showing kind of Twitch videos which are shared online, and that is what the people want to do. They want to kind of, on the one hand, compare themselves to others. They want to show off. If you reach that one with a training, you can't win.
Michael, I have a question for you. For many years, I have really struggled to work in the virtual reality area. I teach digital media, and 3D animation and virtual reality has traditionally made me very nauseous. And I've had many companies come to the university and say, "No, that's sorted now. It's sorted now. The speed is there. It's sorted." And I've yet to not feel sick after it. Are we there yet?
Depends on.
Okay.
That's a clear answer. No, we have glasses that are of an enormous quality nowadays. Like if you're looking at the glasses of Vario, it's unbelievable. So Vario Aero with a really high resolution, and but you need to have the proper PC for that. If we look at the let's say cheaper glasses like the Meta Quest 2, which is roughly 450 euro now at the moment, it's a very good device, and for that kind of money, it's one of the best devices you can buy, because I don't think they produce it for that money. But you have to distinguish between what you're using it for. So if we use it for the typical gaming, like kind of Beat Saber or any other things like we talked about today, or such as security training, you don't need to be that detailed. So the resolution is not in the need of being a very high resolution. If we talk about other applications, so we have done one application for the Imperial Palace here, because they have the problem, they are in charge of all the cultural heritage sites in Austria. And that means they have 3 experts sitting in Vienna, and they getting called if there's a crack in the wall in any of the cultural heritage sites. So what they do, they jump into the train, they drive there, they arrive there, the crack is in 4 meters height, and said, well, I'm going back again because that's 4 meters and we don't have anything to go up there. Call me again if you have anything arranged there. So we did a flight with a drone. We did a high resolution scan of that, really high. We got them really very critical. And sitting in Vienna, we sent them the data, they put the glasses on and could really take a look at every crack in 4 feet, 5, 6, 7 meters height by simply flying with the drone and reconstructing it. But that, if we're talking about kind of 2-3 hours of work nowadays, if we look in the future and we can do this automated by smaller drones, by much better drones, that will be kind of a game changer for that, because they can see, they can't touch it, they can't feel it nowadays, but they can look at it and simply decide, do I need to go there or not? And that's a big one. And as you said, for the 3-dimensional objects, currently we are under kind of checking for if it makes a difference how high the resolution is for walking and working in that. So we have done our kind of conference room that we have at the university in very high resolution. We have done kind of 4 or 5 tables in there where the people need to solve kind of puzzles, riddles, stack up kind of blocks on each other. And this is done in a high resolution. And we checked which movement way, kind of free movement, teleportation, or omnideck is perceived best. But now what we will do is we will stay with the teleportation because, well, we know that the omnideck is not very kind of highly distributed over Europe because there's 5 of them. We will make this in different kind of resolutions. So half the resolution, a 1/10 of the resolution, and comic resolution, and then see if this has a real impact. Because I think for the training and for the perspection or the impression that you have, the resolution is not that important.
Okay, thank you.
Okay, maybe we'll take.
Oh, the receptors in smelling devices. Yeah, that was kind of tricky. I think they had those little kind of smelling blobs that they could kind of press by pressing it. There were 2 or 3 smells that you could use. It was really interesting. And the other solution was a whole cabin like you have in a sauna, and you were sitting inside and they were kind of bombing you with smells. It wasn't very pleasurable, but it was kind of different. Let's put it that way.
Thanks a lot, Michael.
You're welcome.